Hello friends, you are highly welcome to this class. This is mathematics class, and today we'll be looking at this factorial notation. So in this class we'll be studying factorial notation, how to simplify a given expression that has to do with factorial notation. So assuming that you have a positive integer n, then you want to evaluate n factorial, we define it to be equal to n multiplying n minus 1 multiplying n minus 2 down to 3 multiplying 2 multiplying 1. So this means that if I have a positive integer n and I want to find the factorial of it, so I have to expand the positive integer by multiplication. I will expand it down to what? 1. So I will start with that positive integer, then I will multiply it by the lower integer till I reach what? 1. Assuming that you are told to find 5 factorial with this. So 5 factorial will be 5. Then next integer smaller than 5 is what? 4. You are going to go down to 1. 3, 2, 1. So 5 factorial will be 5 times 4 times 3 times 2 times 1. Likewise, 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. This is how factorial notation works. Then, assuming you are told to find 1 factorial. What is 1 factorial? 1 factorial is what? 1. Because you can just say 1 times 1, which is what? 1. So 1 factorial is what? 1. So with this, let's see how we can use the factorial notation to solve this very question here. So they ask us to simplify open bracket n minus 1 factorial divided by n factorial minus n factorial divided by n plus 1 factorial. So this, what we have here is a fraction, right? And you know, if you want to simplify fraction, you need what? The LCM. So the question is, which one will be the LCM among the denominators? Is it n factorial or n plus 1 factorial? Of course, n plus 1 factorial is bigger than n factorial. Let me show you that. N plus 1 factorial will be equal to, you are going to write the number you have first here. As we have 5 factorial, start with 5 before going down, right? So n plus 1 factorial, I'll start with n plus 1. That's the first thing. The next thing, you multiply it by what? You minus 1 from it. As we expanded 5 factorial, I wrote down 5. Then if you minus 1 from 5, the next smaller one will be what? 4. So as I've written n plus 1, then I have to minus 1 to get the next smaller one. If I minus 1 from n plus 1, so I will do n plus 1 minus 1, which will be n. So the next one I have n multiplied by what? N down. You are going to keep on multiplying till what? You reach 1. But I will just stop by writing n factorial. So I will expand this as n plus 1 multiply n factorial, because I don't know what n is actually, because this can go down to what? 1. So I'll just stop at this. So it means that the LCM will be this, because n factorial can divide this quantity, right? And this quantity can divide itself. So I will take this as my what? LCM. So our LCM is equal to n plus 1 factorial. So that's our LCM. To simplify fraction, you have to write the LCM down, right? N plus 1 factorial. I've written it down here. Then you go to the first fraction. You use the denominator of this first fraction to divide the LCM. Remember, we expanded n plus 1 factorial to be equal to n plus 1 multiplying what? N factorial, right? So it means that n factorial, if you divide this LCM, if you divide this n plus 1 factorial, it's the same thing as dividing n plus 1 multiplying n factorial. So n factorial will divide n factorial. What is now left is what? N plus 1. You now use the result to multiply the numerator of the fraction. So I will have n plus 1 multiplying n minus 1 factorial, because n minus 1 factorial is the numerator, right? So you now go to, the next thing we have here is minus. Then coming to the second fraction, the denominator is what? N plus 1 factorial, which is actually our LCM. So n plus 1 factorial divide this LCM, divide n plus 1 factorial, I will get 1. And 1 multiply the numerator, 1 multiply n factorial is same thing as what? N factorial. So we can simplify this expression further. So to simplify this further, you are going to try to simplify the numerator and the denominator to see if something can cancel what is at the denominator and what is at the numerator. So I want to factor common something out from the numerator that can cancel what is down at the denominator. So let's just try to know if we can factor something out from the numerator. So here now I have n minus 1 factorial. I have n factorial here, right? So if I expand n factorial further, I will get n minus 1 factorial. So this will be equal to n plus 1 multiplying n minus 1 factorial minus, so this n factorial, I can expand it. If you want to expand n factorial, see where we expanded it here. It will start with that n. So you have n, then multiply by what? N minus 1. So multiplying n minus 1. But because we have n minus 1 here, so because we have n minus 1 here, so I will stop here. So since I'm stopping at n minus 1 in my expansion, I will not expand down again. I want to stop here. Since I want to stop here, I will put what? Factorial, because I'm stopping here. Because I did not expand n factorial down to 1, I'm stopping at n minus 1, so I have to put factorial. So divided by what do we have down here? N plus 1 factorial. So that's what we have down here. So if you watch closely, we can factor n minus 1 factorial because it is common from the numerator. It's common. So we can factor n minus 1 factorial. So we have n minus 1 factorial. Then multiplying, I can create a bracket, multiplying. So what is now remaining here is what? N plus 1. Then what is now remaining here is what? We have minus n. Then we'll have divided by n plus 1 factorial. So what we have is n minus 1 factorial. We have n minus 1 factorial multiplying this bracket, right? So, but inside the bracket we have n plus 1 minus n. So n can cancel n, right? Okay, sorry, n can cancel minus n. N can cancel minus n because n minus n will be 0. What is remaining inside the bracket will be what? 1. So if n minus 1 factorial multiply 1, I will still have what? N minus 1 factorial. So at the numerator I have n minus 1 factorial. That's the result, right? Then divided by what? N plus 1 factorial. That's what we have at the denominator. So how we have n minus 1 factorial at the numerator, we have n plus 1 factorial at the denominator. Can something cancel? Yeah, we can simplify the denominator further. We can expand it. So if we expand it, you know, as you're expanding it will be going down as you subtract 1, it will be going down. So at a time we'll be having n minus 1, right? So which will cancel the numerator. So this thing now we can simplify it to be n minus 1 factorial, which is the numerator, divided by, is this down one I want to expand. So I want to expand n plus 1 factorial. The first thing you write what you have first. So have n plus 1. Then next multiplication, you minus 1 from the quantity. If you minus 1 from n plus 1, you will be having what? N. So you have n. You minus 1 again. If you minus 1 from n, you have what? N minus 1. Right? We have n minus 1 here. We have n minus 1 at the numerator. So because of that, I can stop here. And because I did not expand this thing down to 1, so as I'm stopping at the middle, I have to put what? Factorial. N minus 1 factorial can divide itself, I have 1. N minus 1 factorial divide n minus 1 factorial, I have 1. What is remaining at the numerator is 1. And what is remaining at the denominator is what? N multiplying n plus what? 1. So this is the final simplification of that factorial expression. See you in our upcoming class. Bye.